Good morning. Welcome to the Perc meeting at IETF 98. If that is not your intended destination, please disembark the plane at this point. Next slide, please. This is the note well. Please note it well. I should have seen this a few times already. Next slide. So we'll go over the milestones in just a second. I want to pause briefly here. Alyssa is not going to be here, but I'm going to present the albums we have for her anyway. DC has, where Alyssa and I both hail from, has a strong tradition of hardcore punk rock. And I'm not trying to say Alyssa's a punk, even though she is skipping our meeting. But she is pretty hardcore, so we have a couple of albums of that to contribute to the fun. I will get these to her later and make fun of her appropriately for skipping the meeting. Say again? Oh yeah, so one of them is Bad Brains' self-titled album. They're major DC punk group. The other is Nation of Ulysses' 13-point program to destroy America, which I figure could be helpful for her chair planning. All right, Celeste, do you want to take us through the milestones?
Sure. So on the milestones, like since the last meeting, we haven't changed the milestones as such. So we have architecture document, and the signaling documents and the SRTP and the key management all set to be done by June 2017. I think most of the documents that are against these milestones are already in pretty mature state. We'll talk about how do we want to take it to the next level. We'll circle back again on that. So one point to note is that these milestones happen before IETF 99, and so maybe we should schedule some calls if we want to get it aligned for this milestone. So the milestones and the documents. So we have those things that are in bold are the ones that have been against those milestones for a while, and we think they are adopted, and they have been since the last IETF. There's not much changes that went in apart from making sure the review comments are incorporated. So hence the star against them basically means that we might want to see if we can do a working group last call, if people think, or at least decide what we want to do with it. And there are a couple of new entrants for this IETF. One on the WebRTC, Adam submitted a Perc. How do we use WebRTC with Perc? And we have an addendum document for tunnel from Paul, which talks about how to use DTLS-ID. We'll be seeing what we need to do about that, but they align with the current milestones. And Emil submitted a couple of drafts last week, so that corresponds to the RTX. That's not added here, Emil, sorry, that's my mistake, but those things are also the new entrants that came in. So moving on to agenda, we have it looks like a pretty packed agenda. We'll start with Paul presenting the DTLS tunnel and DTLS ID, followed by Adam talking about the signaling with Perc, and then again Cullen talking about the EKT diet and the Perc double drafts, followed by David doing the framework, and off to Emil for RTX for now. And we want to decide on how do we want to do with the work and try to assess where we want to go with the working group. That would be the last few seconds for chairs. So any agenda bashes? Okay. Sorry? We have minute takers, yes. We have Dan, Bernard, and Matt for JavaScript. Thanks for the minute takers. Cool. So can we have Paul? Paul Jones. Cool. There's no tape.
No tape? No tape, all right. Okay, so this presentation is gonna cover a update on the tunnel draft. So we submitted to after the last meeting, we submitted a 0.0 version for the working group. So it's no longer just an individual draft. Go to the next slide. So what's new? There's some editorial changes, not a whole lot. There's an editor's note on conference identifiers, which I'm going to talk a little bit more about. And then we changed the cipher example in section 7 so that it now reads, it actually shows the double ciphers instead of the individual AES GCM ciphers we had there before. So next slide. All right, so the conference IDs, we're going to get much more into that in the when I talk about the DTLS ID draft. So we'll skip this slide. So I have an editor's note on tunnel affinity, and it's not labeled that way in the document, but that's essentially what it is. So the draft currently says that the media distributor must forward all messages received from the endpoint to between the MDD or the MD and the KD. It has to go over the same tunnel. And somebody suggested, at least 2 people suggested, no, we shouldn't have that requirement. And there's similar language between the KD and the MD, so it's just asymmetric requirement there. So the desire is to do something to change this. What I'm suggesting is we have to at least make sure it gets to the right MD or the right KD, otherwise you're sitting who knows where. So what I'm suggesting, since the MD always sends out the first message with the that indicates what its capabilities are, in there we could put in an immediate distributor identifier of some sort. So at least that way, if there's multiple TLS connections between the MD and the KD, any one of those would work. So we don't necessarily have to have tunnel affinity, but at least we have some affinity between the two boxes. So I just want to get people's view on that. If it's agreeable, I'll change that language and introduce some kind of media distributor ID, just be a UUID that the MD fabricates. It would be persistent so long as the box is up.
Adam Roach. So quick question on the final bullet of here. We say if multiple key servers by the same name exist, what name are you referring to? I don't remember a protocol element where we convey that.
So just sorry, that probably wasn't very clear. So it obviously wasn't very clear. Just referring to either the DNS name or the fingerprint, right? So there's ways we can already identify a box, but it's not necessarily the same logical function. So you may have multiple key distributors running on the same box, right? For different conferences even.
Okay, I'm going to think about that a bit, but the fingerprint is probably the answer I was looking for. Thanks.
Yeah, Eric Pasquale, just thinking this through, that's generally not an assumption. This is generally not an assumption you would make in the web context this way.
Right, that was what I was worried about.
Yeah.
Which assumption do you mean?
That everyone with the same domain name was equally good for everything. Yeah. I mean, so I mean, in particular, I mean, yeah. So I mean, web servers go a lot of trouble to maintain consistency of some kind, but you really don't want to have a situation where, for instance, the SLAN geo-distributed, and you assume that that reconnecting from another location is going to be the right thing to do.
I mean, we're deep into designing a high availability mechanism when usually we just sort of stay out of that and leave that to implementations to do, right? But I mean, I get that we might need an identifier here, but we got to totally, we've got to separate, like the name is what's confused the issue here, right? In that suddenly everyone thinks DNS name, right? So whatever the DNS name was that we routed to, we obviously can't assume those will get you to an equivalent server. But we need something else that, well,
The KD must mitigate connection.
fair enough, but it's still, so the KD's DNS address or any geo routing has nothing to do with the topic we're talking about then, right?
I'm not sure.
Oh, okay, yeah.
When I read this, the concern that I had initially was that this may have been referring to like the identity of the conference, and it's like for things that are co-located with a browser, that's going to be the identity of the user. And if I'm on, say, 2 browsers, they're not the same conference necessarily, right? If like this one's hosting one conference, this one's hosting another conference, you cannot treat them as interchangeable. So it needs to be something that is going to be distinct between those two.
Right, so it cannot be the identity of the conference. Right.
Yeah, this is primarily to address a simple thing of sometimes TCP connections break, and then when it happens, what do you do? And it may be multiple tunnels. I'm not sure why people were proposing we have multiple tunnels between the MD and KD, but it would certainly be allowable.
So, ripping off what Adam said, as I understand it, he's saying if the KD is the person who makes the connection to you, I do not think you should be assuming that if you have a second connection to a KD by whatever name it's identifying itself, which again, if it's like a DNS name or a thing in the certificate, that those are equivalent. That does not seem like a good assumption. It seems like you should identifier that indicates a KD context, not assume that the secure identity carries that. You're looking at me puzzled, Richard.
That's okay.
I mean, if the KD is responsible for making the connections, the KD is the one who knows when things are equivalent and should be telling you, not having you infer that from some identifier that was not intended for that purpose.
Yeah, the way the text is written right now, either the KD or the MD may initiate the connection between each other.
Okay, but I mean, the extent to which we're referring to, but the media server knows about who he can talk to, who he can send things to. Yeah, it seems like the easy way around this problem is to have the KD have an identifier that is a contextual identifier that it feeds the MD, and any two people with the same contextual identifier are the same. Any two people without the same contextual identifier are not. And then you're free to use a fixed string, and in which case you get the behavior it says here. But if you don't use a fixed string, then he has to adapt.
That seems like the cleanest thing, is going ahead and separating this out in its own concern. I actually got up to say something different, which was more associated with your aside. There was a change apparently that I missed. I thought we had consensus that the connection was always from the KD to the MD. I'm worried that if we have a specification that allows it in either direction, you're going to end up with MDs that are fundamentally incompatible with a browser co-located KD architecture, and I would really like to avoid that.
So a challenge, an issue with that is in the environment where I'm trying to deploy KD, we're using one of potentially multiple key distributors. The key distributor doesn't know necessarily which media distributor to talk to. In fact, there are multiple media distributors in any given call. So from my perspective, I want the opposite connection to occur because the key distributor doesn't even know to go initiate the connection and where to go initiate the connection to. So it gets a bit complicated. So I think we have to allow for both. And I think it's going to depend on how the conference is constructed.
I suspect that what you probably really want there is some way for the MD to reach out to a KD and say, hey, you connect to this destination, which is, I mean, if you look at the flows we're going to be talking about next, that's kind of the way things are hanging together, at least in the way that I've described them anyway. It seems a lot more sensible to just maintain that the connections are always done in the same way, right?
Yeah, I think we need to work through that a little bit more.
Okay. Probably if we have enough time in the session. I remember we only had about 20 minutes for this particular slot.
We have 7 minutes remaining here. We can also, like the slide before it said, or the chair slide said, we should have some calls between now and the next IETF. So this might be a good topic. We can punt topics up to those sort of calls.
True. So I think what might be missing here then is, in the same way that I've done kind of a signaling, here's where all the data needs to go for the situations I described in my draft, we probably need something equivalent for a standalone KD, and we can sort of work through what makes sense there. It's not clear that all the information is getting to the same places in the same way, and I really don't want like two marginally related but divergent systems here.
So I have no dog in the fight of who connects to who, but what I don't want to have is 2 minutes of discussion followed by non-resolution, followed by 2 minutes of discussion, some other thing followed by non-resolution. So I'd like to put the agenda bash that either someone comes up with a...
Yeah, I totally agree with you. Let me close this one with a resolution.
Okay, but I'm going to say the same thing on the next presentation, but fine.
We have diverged off to a completely different problem than what this issue is about,
Yes.
which was purely about how to come up with a connection. We've come to the thing that we need an identifier. You proposed a UUID on there. to identify, as Edgar said, the context of this connection. We may need one on one end or the other end, but I mean, that's the problem we need to solve, right? And for this issue. So can we resolve to go add those identifiers, UUIDs? Obviously, we can't use the identity of the conference. That doesn't work, right, as Adam pointed out. So can we add a UUID to this that identifies the context of the KD, that effectively names the KD pool and the MD pool? Right. I think that nails it. No matter, all those other issues still exist, but like that closes this one. Right? Yeah. Okay.
I guess now what I do want to say is, how are we closing Adam's issue? Because I want to make sure it does get closed, because I want to make progress on at least one spec, rather than have, like, incremental progress on all of them, right?
So I feel very strongly, we are not specifying in this working group everything that you need to make a KD and MD interoperate together. There's millions of stuff, every conference bridge ever made, the thing that deals with the signaling, I mean, we can't do that without specifying how all the signaling works. I'm talking about the call control signaling. We've left that all out of scope. We were just trying to do the media layer here. And so yes, there is going to have to be coordination between MDs and KDs and stuff. I got no problem with adding.
Can you put the milestones back up? I want to point something.
I know the milestone you're going to point out. I understand that. It was how those integrated into the environment. It was not how you split, how your KD works with a completely uncoordinated MD, right? That was about how a SIP or WebRTC or CLUE endpoint could connect to a conferencing system that implemented those things.
You're basically saying that the KD-MD interface is out of scope of this working group, and that's all this draft is about.
No, I didn't say that. I said everything that you would need to set up and coordinate to build a full conferencing system, rosters, all of that other stuff, how it's coordinated, how these messages, how you find media distributors, how you find which ones you use, how you scale and load them, like all of that stuff. I mean, I was never in scope to do all of that.
Well, we're expanding a little bit here. I think the focus question, as I understand it, was, what's the directionality of this? The connection here, DTLS has a client and a server. What's the directionality of that with regards to the KD and MD relationship?
Okay. I have no problem with that. I mean, I thought we'd resolve that. I don't remember the resolution, but we clearly spent several hours of it. Let's not rehash it here. Let's go look up what the resolution was last time versus rehashing it. But whatever the answer, we came up to that, either both or one direction. Fine, it doesn't matter. That doesn't change anything. But that does not mean we're defining everything you need for an arbitrary KD to work with an arbitrary MD. I'm not going down that path. That's a huge scope creep.
Yes, we did come to that conclusion, and I know what it was. It was a single connection, KD initiating, which is why I was surprised. That's why I'm up here. This feels like we had an issue that was closed,
okay.
And
Adam, I think that's a
Mistake,
broader
all the editors
architecture
will fix
issue.
it.
Yeah.
Okay, next slide. All right, so this has to do with, there's a message that got introduced called endpoint disconnect. A lot of words up here, but essentially the media distributor can send that to the key distributor, let the key distributor know that the endpoint has left. But we don't have the reverse. We don't have a way for the key distributor to tell the media distributor an endpoint's left. And generally you don't need it, but I came into a situation where the call's set up, everything goes through the media distributor, and the endpoint presents an invalid certificate to the key distributor. The key distributor essentially rejects the DTLS association, but the media distributor doesn't know that. And so it's just sending packets, and it could be a rogue endpoint, just a faulty endpoint, but it should be a call that gets torn down. So the proposal here is just to allow the key distributor to also send this same message back to the key distributor to tell that the endpoint is gone. Maybe we want to reconnect it or rename the message from endpoint disconnect, but that's essentially what it is, to tell the media distributor that the endpoint's gone or should be gone, should be removed.
Yeah. Sure.
Okay.
Nodding.
I'll ponder on a name because I don't like disconnect, but maybe it's an appropriate name. So next slide. All right, so some other suggestions, and these came in relatively late. One is to put a version field only in the first message sent. I don't think that should be an issue because right now we're putting it in every message. That's overkill. Use a UUID instead of the current association identifier. That's perfectly fine, I think. put a message length before the message type, and that's so that we can improve the way that we're doing framing, since it is now TCP. It used to be UDP, which is why we have this current situation. So we'll introduce a message length for each of the messages, and then have maybe add something that's a highest supported version in the unsupported version message that comes back from the KD.
Yeah, so these all seem generally cromulent. A tiny nit is that the TLS convention is to have the message type first followed by the length rather than length followed by the type. It's not a big deal, it's just the way it's done.
It was to have what?
The TLS convention is to have type first, then length, rather than length first, then type.
Okay.
And either of those is fine. That's fine as long as everybody agrees that the types are so long and lengths are so long that still works. So that's just, and the length convention refers to the rest of the everything after. So it's like the record is basically n plus 3 long and length is n.
Yeah.
So again, it's just the
Yeah, I can do that. Certainly no problem.
correct.
Okay, I think that's the last one.
All right, good. You're
I think.
1 minute over.
Pardon?
You're 1 minute over. So let's try one from the time on this.
All right. So, all right. So this is to address the conference identifier issue that I mentioned before. So if you want to go to the next slide. So what we introduced to add, I think at the last meeting, and it could have been before that, we introduced this tunnel identifier, or this conference identifier, and this is, I'll say it's clunky at the risk of getting shot. I think it's clunky. It's a new conference. It's another conference identifier that we have that's only for use within tunnel. It doesn't have anything to do with any other conference identifier that's used in the conference. And so there's not even clarity on which direction it's sent, the MD to the KD or the KD to the MD, and it's still open in the spec. So what I'm suggesting is we get rid of it, and instead, if you go to the next slide, we'll use the DTLS ID. Okay. All right, so there is this DTLS ID that's defined, and it was, I think it first originated in MMusic working group in that draft. If we insert that identifier into the client hello message that goes across the wire, when it arrives at the key distributor, it will know, because presumably they'll already receive the STP, or at least the information of the STP that it needs to know in order to figure out which connection this is. It would be in the clear, which is okay. All right, I've already confirmed that with people. So we can put that in the clear, so that's security is not an issue. So it would just go in as in the client hello unencrypted. If the media distributor needs to use it, it can do so. I can pull it out if it would like. But it would the intent would be that it would go over to the media distributor or the key distributor. The key distributor would then recognize that endpoint. And if you'll, I didn't describe what the problem was, so I'll back up and explain that a little bit. So the reason we introduced the conference identifier is that it's possible that Alice will initiate 2 calls at the same time. And because she's got, and using the same certificate. So I tried to go down the path of requiring 2 different certificates, and that was balked at. So Alice will use the same certificate and initiate 2 calls at the same time into 2 different conferences. And the key distributor doesn't know which conference key to give to which DTLS association. So if we use the STP signaling with the DTLS ID, which is definitely going to be unique per DTLS association, then we put that into the DTLS client offer message or client hello message. Then that will allow the key distributor to unambiguously determine which key to give to Alice. So that's the proposal. Next slide. So it looks kind of like this, and I'll note here that it's already in Martin's document that came in relatively late. His head just perked up when I mentioned his name. So he's got it here. It is defined a little differently in his document. It's 1 to 255. I've got 20 to 255. Minor difference, but that oh, it's an error on your part. Okay, I didn't know which way we should do it, but I'm okay with either one as long as we have some kind of identifier. I'm not proposing that we define this extension in our draft, in the tunnel draft, but make reference to it, whether it's Martin's document or a standalone document. It doesn't really matter. Next slide. So, okay, I think I've already stated all this verbally. So we know what we're getting as expected result out of it. Next slide. So what I'd like to do as far as next steps, if you agree that we use the DTLS ID, I will change the procedural text in tunnel to reflect that. We do have some endpoint specific behavior which shouldn't go into tunnel. Maybe we put it in the architecture document. And then we make reference to Martin's draft.
Colin, sir. Just as a slightly separate issue, Adam had proposed this sign message to go in here. Are we going to discuss that at some point?
Yeah,
today?
that's his presentation coming up.
Oh, okay, perfect.
So, Paul, just to be clear, so because DTLS ID is part of the DTLS handshake, that means that the MD can't modify it as it goes through. So in particular, that means this is a requirement on endpoints joining that they support and provide this DTLS ID.
Yeah, the
Agree with that?
MD could modify it, yeah.
Well, it'll break the handshake though.
Yeah.
Because, okay.
Yes, but the intent isn't for the MD to modify it. I mean, MD can change it.
Yeah, I'm just
Sorry. So what I was saying is, yeah, the MD could modify it, but we didn't have an intention for it to do that. That wasn't the intent.
Just wanted to be clear that this is adding an additional requirement on endpoints to be able
Correct.
to participate in the conference.
Yes.
We do, obviously the MD can't modify it, but the MD does need to be able to read it to know which is the correct KD to send stuff to. So in the client hello, it needs to be unencrypted, which I take it is, but I think that's the only requirement from the MD.
I mean, otherwise, this seems perfectly cromulent to me. And what do folks think about swapping out the conference ID and tunnel for this thing? Any thoughts? Okay, so resounding agreement. Oh, yeah, actually, Paul, stay up here for one more second. There is a question, I guess, Suhas reminds me of which document we define the identifier in. Martin, can you advise on the status of your document?
Yes, so Martin Thompson. There's a discussion in MMusic tomorrow about what to do with this. This all works really well if you're just doing straight up DTLS, but the general problem is that we also have TLS, and we want to solve the problem for that as well. So there's a discussion tomorrow as to whether we maintain a DTLS ID and use that, or whether we define a more generic TLS ID, or whether we define two, one for each type of transport. That discussion will happen tomorrow, I expect. But ultimately, you will still have the same thing that you can rely on, which is that the media section will have an anchor.
Yeah.
And that anchor will be unique, and you'll be able to rely on that for the purposes that you want, and I can rely on that for the purposes that I want. So I think it's the general strategy here should still work.
Okay. So Paul, you agree that if Martin's draft goes through, then we can just refer to it from tunnel, and we don't need.
Yeah, okay. I prefer to refer to something than to create something specific for
Okay,
Perc.
that sounds good.
Okay.
So for the minutes, we'll plan to refer to Martin's document unless that goes seriously awry. Well, yeah. We will follow with interest the discussion in MMusic, and if we need something, we'll define it later.
Hi. Okay. Oh, this is a lot harder than I thought it would be. So I'm going to talk through sort of some. This is high-level data flows. What needs to get where in a WebRTC system that's using Perc. And this is all kind of thumbnail sketchy. It's I threw stuff at the wall and it didn't look obviously wrong. So I want to kind of talk through it and let y'all throw tomatoes. So definitely need feedback, and just as a note to the note takers, there may be significant things to take note of here. So just real quick, what I wanted to make sure was that the Perc model worked with WebRTC in particular, see if there were any protocol mechanisms that weren't currently present that we might need. I actually thought there would be more. The final conclusion of this surprised me a little bit. the current version of the document is just ladder diagrams with labeling for each of the steps. I'm not sure this is even useful to publish in its current form. This is more to foster the conversation around what needs to happen. And one of the key goals here is to minimize the changes that are necessary to make to an already WebRTC enabled endpoint. And in particular, what this means is that I'm relying in these flows on WebRTC identity as opposed to adding another identity mechanism for browsers to implement. That's apparently I have that twice. The final thing is so we have the MD as a monolithic node in this, where I recognize in practice these are going to be decomposed into a whole bunch of different servers. There's an assumption that we don't talk about that API, and they're just shown as like one thing in here. There's an assumption there's going to be a proprietary protocol between those. There's probably some implications from these call flows on that protocol, but we're not going to go into that. Okay, so yeah, next slide. This is the whole thing. We're just going to go through all 68 of these real quick and talk through what they mean. Well, from here I can. So luckily I have broken them down, both here and in the document, into sort of high-level steps. I have this, we're not really going to go through it. It's mostly for, you know, if you want to pull up the slides yourself so you can see the whole flow while we're talking about them. These are all on the proceedings website, obviously. Go ahead and go on to the next slide. I'm just going to take them in small chunks here. So this is basically when we're very first starting these things up, right? Web browser has to go and retrieve the actual application from a web server somewhere. That's what these are. I am assuming that like the URL that we're sending is indicating which room someone wants to join. Next slide. And yeah. So after all this happens, we're going to have some creation of like a key distributor object sort of inside the browser. Now, as a quick side note, I did all of this with the assumption the KD was going to be co-located with the browser. This separating it out so that the KD is a different node that doesn't have that kind of coupling should be a relatively straightforward exercise. But I frankly didn't have time to go through all that analysis. And also I wanted to make certain that we had some sort of agreement on what this was sort of shaped like, because changes here would necessarily ripple through to changes in an isolated KD environment. So I didn't want to like do that work and all the changes twice. Right, so we're going to create a new KD, and in this particular situation, because it's the only thing that we're going to be able to authenticate as, the conference owner, which is basically the first thing that's joining the conference in these flows, even if it's not necessarily like an administrator or any particular useful, you know, more powerful than anyone else in the conference. It's just, this is the thing that's serving as the KD. I'm going to refer to that as the owner regardless of what the actual permissions model of the conference is. So the owner is going to set his identity in here because that's the only thing he can authenticate as, and we need to have some identity for the conference itself owned by the KD. And this is going to look an awful lot like the way that we handle identity on a peer connection in WebRTC. And then in order to perform the next steps, we also are going to have to be able to retrieve the fingerprint from this KD that we've just instantiated. Okay. So next slide. All right. After we've done all of that, we're going to go ahead and do whatever it is that that web conferencing application does internally to say, I'm ready to start the conference. And he's going to have to convey that KD fingerprint in some way to, but it eventually needs to get to the I should say MD. I did this originally with the old terms and then changed it all to be correct, except for I missed some things apparently. So he's going to send that. He needs to get to the MD, but he doesn't have a direct association at this point. So he's having to go by way of the controlling web server that's running the entire conference. So he's going to say, I'm ready to start this. Here's the fingerprint. And then he's going to have to pass that along. The conference controller is going to have to pass this along to the MD so he can know what this fingerprint is going to be in the future and do whatever conference creation stuff is necessary. Ronnie.
Running up.
Yeah, that was why I was so loud up here. I was expecting to be like that one, and that one's very quiet. You kind of have to eat the microphone.
Okay, so a question: how does the the original knows that there will be an MD in the conference in the first place.
I'm sorry, how does which entity know that?
The first joiner of the one who created the conference, how does he know that there's a?
So this is all going to be encoded in this 200 contains basically a web app, right? That's a bunch of JavaScript that is under control of the web server. So it kind of knows how everything hangs together.
So it should know that there's an MD involved in that.
Yes, it's going to inherently know that. Okay, so after this happens, we're going to get back the name of the MDD, the name of the MD, which is important that it's a name and not an IP address for reasons we'll get into in a little bit, and the port number for him to connect to. Now, I've made an assumption here that we're going to demultiplex on port. I think with the conversation we just had around identifiers, that might not be necessary, but we're still going to need to have this just for the purposes of knowing where to connect to. So there's some text in the document that probably needs to change to accommodate the ID discussion we just had. Next slide. So at that point, we're going to have, the application that's running in the web server is going to, the web client is going to call connect to that, and he's going to set up the connection using, for the tunnel protocol itself. He's going to make sure that the cert presented by the MD matches the name that he used to connect to it. So this is basically the same validation you perform when connecting to a web server. And the MD is going to make sure that the fingerprint of the KD matches the one that was conveyed to it in the original steps.
So, Emilio, this it's not major because you said we could use the DTLS ID there, but port might be problematic either because if this is a connection that's coming from clients, you probably just want to use 443 for everything. So, I don't know if you want to rely on being able to multiplex on ports.
Okay.
When I went through Adam's things, think it works totally fine if you don't demux on port. I mean, I think I took his flows as just, you could implement it this way you want it, but I mean, you have the DTLS client ID, the DTLS ID to demux on or other things if you want to use the same port for all your conferences.
And I'm not calling this as a problem to the model. I just want to make sure that port is probably something we want to avoid.
Right. And to be clear, these flows are intended to be illustrative rather than like normative. I'm trying to make sure there is a path through this that works, not define the only path that people are allowed to follow. Okay. So this all seems to hang together so far, apparently. There aren't a lot of major comments. And I think that's the end of this flow, right? So this is all of 411. If I go, the next slide is going to be 411. No, okay. What else we talk about?
Explain about just how what names were checked in the cert. The very last couple steps, I sort of got a little bit lost on there on what you're checking with the TLS.
So go ahead and pop back one. So that was what I was saying is the reason that we're conveying a name here back to the client is because he needs to perform a certificate check on the MD as a server when we connect. So he's the TLS certificate, the TLS server. So we're going to get back a cert. We're going to use our normal, chain up to a trusted CA.
But is it really the MD that has that cert, or is it the KD that has it? And the connection was tunneled through the MDD to the KD?
Yeah, the MD is a transporter entity.
The MD is what?
No, this is the KD and control channel, not the calling check.
Oh,
yeah, it is.
Okay, that's where I'm lost.
Sorry, this is a tunnel protocol.
DKG. Sorry. Sorry, this is, I don't know very much about Perc, and I'm still trying to understand, so thank you for this. This is actually a really useful thing. The KD's fingerprint that it gives that then gets passed to the MD.
Right.
That's a fingerprint of the KD's.
For the client connection. So that will be different each time.
Okay, so the KD is spinning up a new like self-signed cert.
Yes, in the same way. So if you're familiar with the way that WebRTC peer connections work, unless you pass in a specific certificate, each time you start it, you're going to get a new cert and hence a new fingerprint. That's the same model I have in mind here. So
okay,
yeah, I know what you're thinking there. You don't want this to be some sort of super cookie that you use to track people across conferences, and that should not happen, right? It's a W3 matter, right? But I'm very cognizant of that being a problem, and so if there's work that comes out of this that goes in W3, I'm going to make certain it takes that into account. All right, so 2 slides forward, I guess then. Or actually, I guess we didn't finish this. So, but this is just sort of the normal tunnel setup stuff, right? We're going to get a list from the MD back of what its supported profiles are. And then, you know, we basically say, yes, this worked. The connection is established. You can move forward with the rest of the conference. Okay, so second round. Now, you'll note there are different players in here, so don't get the lines confused with what they were before. We've now got an identity service off to the left. So after that KD is all set up, we're going to start, you know, the user says, yes, I'd like to join. So we're going to create a new peer connection. We set an identity, and this isn't necessarily the same identity that we used with the KD. It doesn't have to be. It can be. It's whatever the person sitting in front of that browser can authenticate themselves as. And whether that's going to be the same or a different identity is up to the actual web app that's been downloaded. So we create an offer, and because we're using identity for these, we're going to go ahead and do the normal dance that we use for WebRTC identity, which is basically, and this is a little bit arcane, so you might need to go off and read the WebRTC identity specifications and reread the security documents to sort of understand how it all hangs together. But the notion here is that we go to a well-known ID on the domain that is associated with the identity being asserted and get a script back and run that script to sign the SDP. Do you have something to say to this?
Go ahead, finish.
Okay. And so it's, in most cases, what you can end up with is that script will say, okay, I have to go ahead and send this off to the server because he has the private key, and gets back a signed version of it that he then uses in the actual offer.
Eric Sperla. Yeah, okay. So I just want to clarify something I think is the case, but I want to make sure it's the case, is that from the perspective of other people in the call, in the conference, they all have a call to the person in this, in the person that you just described getting identity assertion, right?
So technically, they have a connection to the identity that was put into the KD,
Right,
not
yes.
into the PC.
Right, so yes, sorry, yes, right, yes. So, which also tied to identity assertion.
Yes,
Right, okay. So.
which may or may not be the same identity.
Right, fair enough. So just to be completely concrete about this, you invite me and Richard to a call, and you are the KD, and we both think we have a call to you, whereas we actually are in a conference.
Yes.
Good, thank you.
Okay, so and again, so even step 8, this is just part of what normally happens when you have identity asserted on a peer connection. We're going to get back the answer and post this to, so someone pointed out the URL here is not quite right. But that's, again, it's illustrative, not normative. We're going to post this off to the web server. You know what? We're not actually stepping through the steps. Okay, I think I spoke through most of this. Go ahead and go to this. So, right, said that. Said that, okay. Yeah, and I explained all of that. Right, okay, so I basically said all of this, I just said it on the opening slide. So no comments on how all of that hangs together then. Okay, so at this point, the conference itself is going to get the offer and create an answer. Now, he needs to send an answer back that has been signed by the WebRTC identity mechanism, right? But he's not a WebRTC client. So what we need to do here is have him ask the KD to sign this on his behalf, right? And here's the first thing that we come across that we're going to need a new message for, because he's going to have to be able to return an answer that indicates that he is the identity of the key distributor in this case. So we're going to pass on to the KD I want you to sign this answer. We indicate actually go ahead and step into it because I don't remember why we have to have the offer here, and I think the text says why. Right, no, it is this one, and I thought I had an explanation here, and I'm blocking on. We got to a point where it's like we need the offer in there.
So this one, so watching you explain this, it made me think that it would be easier in discussing these two identities, that the identity of the bridge we use as an example, fluffy dash bridge at KD.
Right.
My other identity is fluffy for the user, right? Maybe somebody has two identities.
Yes.
So on this one, I was lost on this. It seemed to me that you didn't actually need to sign the offer. You only needed to sign the fingerprint. Or list of fingerprints, actually, given, like, exactly matching how it works in WebRTC, right? So the list of fingerprints is all that gets passed up into that is mine.
Okay, I think that is correct.
Okay.
So I apologize. I hadn't read this draft. I'm getting a little confused about how this is supposed to work. Do you have a diagram of the topology of the connections rather than a diagram of the message flows?
Not in the document, no.
So I'm trying to figure out why are there two DTLS identities floating around here? Why are there two identities floating around here?
Because you have the identity of the KD, and then you have the identity of the peer connection. So in one capacity, you could theoretically, although I don't imagine anyone would ever do it this way, you could have a KD running in a browser and that browser not participating in any other useful way. And then you would have someone, everyone else in the conference joining and only seeing the identity of that KD.
So I agree with you on that point. But I guess the way I've always thought about this is that there was a KD in the browser and then a pile of peer connections floating out in the world and one of which might be associated with ours and one might not be, right?
Yes.
Let's let's take the simpler case, the one you just indicated, where for some reason the KD is in the browser, but there's no associated peer connection in that browser, right? So in that case, we need identity for that, and that identity seems to now be associated somehow being glued on to. I guess I'm trying to understand what's happening here. Why am I signing anything? What am I buying? Are you trying to bind the rest of the SDP produced by the MD to the public key of the KD?
Yes.
So I think for the reasons Colin indicated, that is unnecessary. Namely, that I think you simply send the thing you would have generated as an identity fingerprint. You essentially you're in a stub SDP, right? That has whatever your crazy media has your identities and whatever your crazy media parameters are, and you provide it to the MD. The MD removes all your crazy media parameters and replaces it with its own crazy media parameters, and then keeps your fingerprint in it. Because we specifically designed the identity mechanism of the fingerprints for a lot of substitution and modification of everything other than the keys themselves. So I don't think you need this transaction at all.
Okay, so the problem that I don't know how to solve is then when, for example, Martin joins this conference, he's going to need to get an assertion that fluffy-conference is the identity he's connecting to. How do we get him a signature that says that?
I think it's the same one. So I guess,
But the problem is the identity. This comes down to the fact that these are two identities, right? The identity in this offer is going to be fluffy at, not fluffy conference at, right? So if I have going to the degenerate case with the KD running in browser A and no peer connections, the first person who joins is going to have an offer that he sends, and that's going to be an identity that the MD and the KD have access to. But the KD hasn't provided an identity at that point.
I'm extremely confused. And for the perspective that the KD has, I think you will agree, N call. So the KD has effectively N DTLS connections for the N participants in the conference.
Right.
And he is the N plus first participant, but he's not on the call. He's merely the key material focus. He's the center of the star, right?
But he's not participating in the conference in the same way. So I mean,
Yeah, right. So I guess imagine the thing of argument we were not building Perc, right? Imagine the thing of argument. Imagine a different design where and I think I made this comment to Neil earlier as well as a way to think about this. Imagine that we had a broadcast topology rather than a star media distribution topology, right? So in that case, what we'd do is you would set up NDTLS connections to the key material focus, and then someone would just give you the broadcast parameters, and you broadcast all your media using the established keys, right? Do you agree with that?
I mean, that would work.
I believe this is exactly the same situation, except that the DTLS connections are tunneled through the media for the MD, right? And what accomplishes the mean tunnel for the MD is replacing the KD's media parameters with the MD's media parameters. That's all that has to happen.
Right. Okay. So
So my point is that what I would have expected I would expect if we assume that the KD is the answerer and the other people are the offerers, what I would have expected would be that that through some channel, presumably the signaling channel, the MD would supply to the KD, the MD would supply to the this HTTP channel rather. The MD would supply to the KD. Here's the offer from the new conference participant, and you would reply with an answer with an identity assertion attached to it, and then the MD would simply strip out all your media stuff in his zone and send it back.
now you're saying that's going over which channel?
This HTTP channel, the one that is associated with the KD being the conference bridge, because yeah.
Okay.
So I mean, it's the same topology you have here. It's just not like it's not like it's signed. It's you send a complete piece of SDP, or I mean, you don't have to, but I mean, but no, you don't. Be a dick.
Sorry. I think you're making this a lot harder. So non-toxic. Because you've got the tunnel thing, the endpoint that's talking to this conference bridge is talking to the MDD, right? Not the MD. Yes?
It's talking to the what, not the what?
The participant in the conference is talking to the MD. That's where the connection it sees is going.
Yes.
Right. It's got from the sort of packet layer, that's what's going on.
Yes. And okay,
the
go
only
ahead.
thing that then the MD is responsible for forwarding everything onto the KD and whatnot, right? So the ultimately the certificate that it sees is the KD's certificate because it's being tunneled through.
Yes,
right?
that's what needs to happen.
The only thing that the MD needs to do is have an identity assertion on hand and the fingerprints for the KD so that it can shove it in the media that it in the offer or answer that it generates. That's all it needs to have.
Sure.
Yeah, that makes sense. Don't have what?
I'm sure that Jonathan's going to tell us there's some complications, but fundamentally that's really all that we need to have here, is because the participant in the conference from a cryptographic and identity perspective is talking to the KD. So all you need are those two things, which are all we need to establish that.
So, okay, what I'm hearing is we would pass the signed fingerprints over this, basically the proprietary application level, right? The web app would be responsible for passing to the web server, and he passes it down.
So, Martin, I think it seems to me what you're describing here, Jonathan Lennox, by the way, is designed to UKS attack. Because basically the MD is sharing the unknown key of the KD.
No, the MD.
I mean, sharing the fingerprint of the KD's key of the KD's certificate. And particularly, I'm wondering how DPS ID is going to work with this.
When you get to the DCLS ID part of this, what you need to do is ensure that the KD is aware of the DTLS ID that the participant is using, and the participant is aware of the DTLS ID that the KD will use. And that's the communication that needs to happen in addition to this. And Jonathan's right. Yes, if we did it just as simply as the two pieces of information that I said that could be configured in, then you do create the UKS scenario.
Okay, so we do need, I didn't quite follow that. Your assertion is that we do need both of those in both directions. So that points to a different new message on this interface, and that's fine.
No, I'm not following this. The entire design concept for this thing from the very beginning is that the client thinks he's talking to the KD, but he's actually talking to the MD on the media, from a networking perspective. And so, I mean, you need whatever information would have ordinarily been in the communication from the KD that you're authenticating based on needs to continue to be there, and the other information, the ICE parameters, do not continue to be there. I mean, that's
right. But we have stuff that must go in the SDP fundamentally, right? We need to figure out how to get that there. I mean, what I heard, and I was quite happy with this, was we could do this at the application level, because that means we don't need any additional messages here, but then I just heard, although it did not completely follow, that we might need to convey some sort of participant ID to the KD in some way, although I guess we can do that on the signaling plane as well, yeah. Okay.
Ronnie, what's confusing to me here is the thing that what you call an MD is not what we call an MD in Perc. Because in Perc, the MD just does the media, but you're talking here about the signaling part that goes on top of that.
Right, that was the caveat I gave up front.
I think it should be more clear if you distinguish between these parts in the description and explain what's going, because there is something going between the signaling part and the MD Perc part. And that would probably make it clearer to understand all this, because this part is just the signaling part.
Okay. Now that might not be necessary with the rejiggering that we just talked about here. So I think I need to go back and rework the flows based on the suggestions we just got from like Ecker and Martin. And it may make that distinction unnecessary. But if it's not clear, I'll go ahead and try to break that apart also.
I think you have to break that apart. These flows will be confusing for everyone forever until we break that apart. We need to break that apart.
Okay.
Nothing to do with this issue, even just the rest of the flows.
Just in general.
More sense. Yeah.
Okay.
Time check, 10 minutes.
All right. I mean, that was really the biggest part because that was the only thing that I thought we needed a new protocol element for. So I think that's almost like a, that's the hard part. Everything else is pretty straightforward. And if we don't run in, if we run out of time to finish all of these, I think that was what I needed.
Adam, for the notes taker on this one, we are saying that you'll rework and come back.
Yes, I need to rework how the fingerprinting works, how the MD basically ends up asserting the KD's identity.
Okay, thanks.
Okay, so let's go ahead and hit the other slides here. Let's see if there's anything else that is particularly trying to think if this bears on the other thing that I thought might be somewhat controversial. So under these circumstances, the way that we've described things, when you end up having the identity of someone new joining the conference, let's see, does this actually change? I don't think it does. The KD is going to have to perform the RTC web identity validation process at this point, which the way that's described, it involves downloading JavaScript and running it, because that's how you verify identities in a WebRTC system. Now for this, obviously, that's not a big deal at all. You're already going to have the KD running in a JavaScript environment. What it does mean is that for a KD that supports WebRTC, to verify those identities, the way that this is described at least, we're going to need to have some sort of Java runtime environment in the KD. Now I know, what did I say? Oh. I don't know how I made that mistake. There was a recent very nice, like, Java is to JavaScript as ham is to hamster. It's like, go ahead.
I prototyped that in Node. It was really trivial. I don't see this as a big deal. I do think it's a slightly more subtle than you get at. One of the things we always avoid discussing in WebRTC is which identity providers you will accept. And obviously, you only need to support whatever protocols the ones are you support, which might move you away. I mean, I'm in agreement with what you're saying. I'm just saying this gets a lot more complicated once you figure out how are you going to decide what identity providers you'll support. In a normal WebRTC call, nothing to do with Perc, right?
True, you can define a closed environment where this isn't necessary.
I mean, so
What would open mean?
In this context, it would allow selection of an arbitrary third-party identity assertion.
So if I provide an identity that says, Alyssa Cooper, signed by an IDP running at evil.com, like we're going to just, is that wrong?
no,
That's the nature of identity. That's what we've taken on as the definition of identity in WebRTC.
I mean, so the way that identity works in WebRTC is that identities are scoped because they're effectively 22 names, right? So yeah, like the whole purpose of the design concept was supposed to be that essentially you didn't have to trust any identity provider because the names are always qualified within the scope of the identity provider. Now, it might be the case So that might be the case that you would give some special treatment, and in particular, you might, for instance, allow some of them for some configured reason to present unqualified names or to assert the name should be dequalified. So like what you're allowed to represent is alyssa.cooper@evil.com. It might be the case that some browsers would be configured that if like superevil.com sent them an identity, then they, whatever crap on the left-hand side, they would display as the actual name, like with a EV certificate. But the system doesn't require any of that. The whole idea is supposed to be that you trust that you try people are authoritative in their own scopes.
Right.
I just want to say one more thing, which is there's no reason, by the way, why you have to be a JavaScript entity to generate identity assertions. If you're generating them with you can have your own private contract with identity provider. The reason why you have the JavaScript runtime to verify assertions is precisely to allow universal verification.
Right. Although if you wanted assertion of any random identity, then you would, yes, then you need to.
Ronnie, the question, why do you need to do the identification of the user in the KD and not in the HTTP server when he joins the conference?
So it depends upon which of those entities you're considering to be trusted and which you're considering to be semi-trusted, right? So the system that I'm contemplating here allows you to have a semi-trusted HTTP server because the notion is this has to be able to be a hosted environment, right? So I'm going to, ibarelytrustyou.com as my conference provider, and it's sending me JavaScript. Well, I didn't say I didn't trust them. I said I barely trust them. I don't trust you with my media, right?
Yeah, but
So
because I thought the HTTP server is trusted according to the Perc.
it can't be. In this environment, it cannot be, right? That's the whole notion. Is this is a hosted service that I'm.
We can't allow the HTTP server to be able to man in the middle the fingerprint and signature. That's the issue, right?
Right.
I mean, if you're running a conference service that you want to access control somehow, you might authenticate someone to make sure they're like an authorized user, but that's independent of the end-to-end authentication, which the endpoints do to each other to make sure that the website's not man in the middle of the traffic. So there's potentially a few different levels of
different
authentication.
IDs that I will need to have for that, because the HTTP server will need to authenticate the user to join the conference in the first place for some reason. I mean,
Sure. Yeah. There's an identity that the endpoint authenticates the server when it establishes the conference if that's required. But the main concern here is the identity that the endpoints assert to each other.
Okay, that's a question. I mean, of the Perc, of what Perc is about, because I didn't understand that Perc is about also. It's only about the media itself, not about the user itself that is authenticated. Just that the MD is not to see the media, but has nothing to do with the users.
So let me give the more concrete example here, right? So I know the people in the room in Cisco don't get bent out of shape when I mention their brand name. So I go to webex.com, right? Well, because WebEx does this also, right? I go to, and everyone in the room knows what WebEx is. I go to webex.com and it's going to send me some JavaScript. And specifically, I have a contract with Cisco that, they're going to carry my stuff and we're set up such that they have an assertion, cryptographically, I have no way of getting a hold of your media, right? So that means that the thing that I'm contacting as, a person joining the conference is in the semi-trusted environment. They must be, right? Which means that they're not in a position where they can say to me what the identities of the people in the room are, because that would allow them to lie and insert themselves. The only identities I can trust are the ones that are coming from the key distributor, because that's a node in the fully trusted environment. The key distributor is something that if it gets a hold of the media, it doesn't violate a trust boundary.
That's the basic separation we've been after here.
I do want to mention it is not in fact necessary for the HTTP server to authenticate the user at all. I mean, if you're willing to have, so say you're willing to have a conference, I mean, the reason to authenticate the user at all is essentially for access control, not for if I want to bill, right? If I'm running a free service, I don't care how many people use it, or I'm billing the KD for it, like you might be a WebEx where you use the operator. Then you don't actually need then then, you may not care, right? If he's willing to accept all callers. So, we have lots of, and this is not a surprising scenario, right? Like I've been on hundreds of conference calls where someone gave me a phone number, I dialed that phone number, and no one attempted to validate who I was, or maybe dial a PIN, and it just let as many people in as joined, right? So that's how this session is being broadcast right now.
Right.
5 minutes left in.
Thanks. Okay, that was the only thing. Go ahead and pop through here. Make sure there's nothing else I've tagged for. No, this is boring. This is boring. I mean, it's all another draft anyway. Skip. Yeah, this is basically, this is the other side, and it looks pretty much the same except for the KD lives in the other browser, so you can go ahead and just pop through all of these. Pop. That's fine. No, skip. That's the same. Skip. So new stuff we need. This is actually not for this working group, but I just wanted for people who sort of interested in the completest view, they can look through this and make sure if you understand the W3 side of things. When we're done with all of this, I'm probably going to have to bring something to W3, the web RTC group, and say, hey, we need something like this to instantiate a KD. I'm not going to talk about it here though. And then these are the things that we decided that we don't need, I think, and that's the end of my presentation. So I got really good feedback. Go ahead.
So you sure we don't need to call this once, roughly? Okay, we don't need the offer and answer. We would need only, you sure we don't need a message to get the fingerprints signed by an identity provider for the bridge? So
I'm not sure of that. That's why I need to rework the flows. And that was what I was saying, is I'm not certain once we have those identities on both sets of the ends of the KDMD, whether we need, whether that obviates it or if that makes it necessary. It's
okay. I had become convinced, particularly for the case where, let's say, the degenerate case where you're using a different identity for what you use to be in the call and for the name of your bridge, so the fluffy bridge case. I'd come to convince in that case that you actually did need a variant of this message. You didn't need to call it multiple times, but you needed to call it once. And it needed to provide back the fingerprints that you would be inserting, that the MDD would be inserting in the SDP of the answer, so that it's sent back to everyone else that joined. So I think you still need.
that doesn't sound wrong, but it's also not obvious. So
okay, so work through all the flows and yeah, okay.
I will always jump. Can you go back one slide? Is this thing on?
Yeah, eat the mic.
Even worse than usual. This object you're talking about here, does it need any special powers, or is it just something that could be in JavaScript?
What it needs is, it needs to have the same identity execution environment as peer connection, which means there's stuff hidden behind here. The JavaScript must not be able to get access to.
Okay, so it needs to talk to the identity provider?
Yes.
And it needs to talk to the identity provider through a privilege interface?
Well, not a privilege interface per se, but it's going to get information there that can't be, like the certificate involved here cannot ever be exposed to the JavaScript.
Okay, I get it, I think.
It's I named these methods very similarly, or I think identically, to the ones in peer connection. So if you sort of work through what these do in PC, that's what we need with KD, with the exception of we also need to be able to initiate this connection.
So more properly, the private key cannot be exposed to the JavaScript. Certificate, of course, can be.
Right. Sorry.
Yeah, I mean, this is like, the way to think about this is this is like a mini peer connection that doesn't actually do any audio video. And otherwise, it's got to behave like a peer connection, but in terms of protection of the key material. You can also overload peer connection with this. That'd be another way to. I stay out of those questions of API design, but yes, you could also do that.
I thought about how to do that, and it's pretty horrible.
Ben Schwartz, Jigsaw. Okay, how many round trips does this take? Because
well, there were go to slide 3. There are a bunch of, I mean, you can count the lines, and I think if I remember correctly, this one's labeled like 66.
Way less than setting up a WebEx call today does.
okay, I just want to remind the working group that
implementers actually care about the setup time for calls and are willing to go to great lengths to reduce the number, reduce the setup time. So things that increase setup time might be hard to deploy.
Right, thanks. And I am sensitive to that. This is a situation where it's like, for Perc, there are trade-offs. And one of the trade-offs is going to be that you're doing a lot more to make these security properties true.
Magnus Westland, but not all of those is actually going across the network. All those.
Oh, right. I forgot. I was actually showing internal API calls to the peer connection and KD in there.
So Martin Thompson, what's shown on that slide is probably the fully extended version of something that's, there's a lot of messages there that are sent at the same time. There's a lot of messages that can be parallelized. You'll find that it's not awful in the end.
Right. I mean, Benjamin's point's a good one, but I'm in the same camp as you. I think that once we get this implemented, it's not going to be horrible.
There are a couple of extra round trips to add the KD into the situation, but fundamentally, this is not much different to setting up a call to the MD.
Yeah.
Conference calls are hard, right?
My previous answer was too flippant, Ellen, but I mean, I think this actually, when you think about it, is almost identical to setting up a normal peer-to-peer WebRTC call between the two endpoints with where the signaling went to a web server in the middle, because there's one half of it's like you do the identity wiggle over here, you do the process up there, and then the going down to the KD is much like the other half of the WebRTC call, but it doesn't have to do the wiggle there. Actually, I think this flow is probably faster than setting up a normal WebRTC call when we actually go through it.
Okay, let's wrap this up after Emil. So please briefly, Emil.
Emil, so quick question. I don't think the answer is yes, but can you think of any implications if the offers weren't coming from the clients, but calls were initiated from infrastructure?
I hadn't thought through that exactly. I mean, there very well may be, just because you end up with different directionality. I mean, there's things sort of piggybacking on things here, and that might make that more difficult. If you'd like to grab the document and do those yourself, I'd be happy to give you the source.
It'll be good to keep that in mind because some applications do it that way. The second thing that I wanted is just a reminder. When we're signing things, I'm not sure if we left it at we are signing offers and answers, or are we just signing fingerprints?
It's just the fingerprints that are necessary.
It's got to be whatever we currently do, whatever that is.
Okay. Because just a reminder, offers aren't necessarily going on the wire, and there is differentiation before, so.
Yeah, I gotta cut the line here. We gotta wrap up.
Now, I do have one last comment here. I'm going to be running out of time here pretty soon. So if there are people who have the time and understanding to assist with this, I would really appreciate a co-author or two. So that's it.
So it sounds like we might want to get at least one more rev on this, incorporating feedback before we talk about any adoption stuff. Do folks think, can I get like a show of enthusiasm for, folks think like something of this general shape would be useful for this work to produce against that WebRTC milestone? Yeah?
All right. Awesome. Thanks, guys.
Spirit fingers, yeah. Okay, great. Thanks, Adam. All right, next up is Fluffy for Diet. Let the minutes show that there were some good spirit fingers for Adam's talk.
Okay, next slide. So most of what happened in this document is both Russ and Sean sent additional reviews. And we went, it was a great reviews, thank you guys, and we went through all of those and did updates for all of them. A bunch of them were clarifications or just plain, mistakes. The ones that are sort of, key changes, and I'll get to one on the next page, which is sort of a breaking one, but the ones that are worth mentioning is we talked about discarding packets where the SSRC doesn't match. So what happens is when you get this SRTP packet with an EKT key on the end, previously we were just lacking the text that said, hey, the SSRC here that you're claiming you needs to match the one on the SRTP packet that sent this, so all the authentications match. Both of those things are independently authenticated, and the fact that their SRCs match together means you can't cut and paste them in a pack, and we were missing the text on that before. Fixed language around how long the key can be used. There's confusion on that. It was just clarify. Basically, it was written to apply that retransmissions would add up the counters when really they didn't. So, and we clarified how to count that and keep track of it. Related to what I was talking about with SRC, it looked like we're in the place where we say how to extend this spec and define new EKT ciphers, we didn't have any text that said, hey, they have to provide integrity of some sense. So we added that. So basically, those are the changes there. Next slide. So this change will break stuff. But I can't find anyone who thinks they'd be broken by this. And it was that we simply, I kept getting these questions about why this table had, the first entry in it for the first, cipher used 1, and then the next one was 3. And the answer is, well, we deleted 192 long ago out of there, so we had this blank gap for 2. But is there any problem with just changing the code point to collapse the table? There's no technical reason to do that. Everything's going to still work the same. I don't know. Just quite a few emails back around on this, and the real problem is no one cares deeply about this one way or another. So the current draft changed it. That may be a mistake or not. Does anyone want to speak to this? Does anyone care?
Not worth the effort to change one more.
Next. That's it. So
does 3 still have its? Does 3 have the old meaning as well?
No.
Oh, you changed everything.
It just changed everything, and we're working on the basis that we're changing so much stuff that anybody who everyone's going to have to change their implementations enough to even make their packet formats line up with this from what they had before. That we won't run into. It won't be like we'll get an old packet and start to parse it. We wouldn't get this far in the parsing. No, I don't think so. Yeah. This is just right. So open issues on this. I don't currently have any open issues with the possible one, which I imagine you're going to bring up right now. And that's.
Yeah. So I think I have 2. I guess first of all, I found this document fairly hard to process, to be frank. Yeah. So I think that would really benefit from a diagram of the key hierarchy. I guess so I have I have 2 substantive comments and things that I would like to at least discuss.
Let's just hit that one first. Totally agree with you. We should add that. Should it go in this document or the framework document?
I don't know yet. Let me think about that.
Okay, let's write it and put it somewhere, and if we decide to move it, we can decide to move it.
I mean, yeah. So, right. So, let me dispense with the thing that probably is easier first, which is I think that the key distribution message that goes in the DTLS channel should go in the application data, not as a DTLS message. And I think you and I discussed this the other day, and I think that the concern people have was that you couldn't was about being able to co-locate data and SRTP negotiation, but we do that all the time in WebRTC. That's not a problem.
So I was confused about that the other when we talked about it. So that was what I thought was a problem, and I was just confused.
Right.
So
Yeah,
right,
sure.
And, but the additional thing that I was thinking about on this that I think that we need to balance off against this is the endpoint, when it dials into a conference bridge, doesn't even know it's dialing into a conference bridge typically, right? It's just dialing a URL. And so it needs to be willing to negotiate and do this always. Maybe that wouldn't be a big deal, even if it would support an application. I'm just wondering if it dialed into some sort of, it's dialing into a data connection. Yeah, I mean, think about how this is going to interface with WebRTC. Like, how do we detect whether a given incoming application data has to do with negotiating this, or is...
So you're concerned with demuxing a potential SRTP channel versus this, right?
Yeah, I think so.
Yeah, So one thing you could do, I mean, so okay, obviously there are a number of ways to deal with this. One way would be simply to forbid bundling, forbid bundling the data channel forbid bundling the data channel with this DTLS channel. Another possibility would be to.
But the endpoint doesn't know when the endpoint creates the offer, it doesn't know what type of call it's going to be.
No, but the other side does. I mean, but you do know what kind of call you're going to be because you're offering the DTLS extensions that indicate support for. Are you going to
We're going to always offer those on all
so,
calls.
So the counterparty, however, does know, right?
Yeah, counterparty does. Yeah.
That's possibility one. Possibility two is that the SCTP header is incredibly stereotypical, so you could demux that layer and claim that offering there's some indicator you're offering that tells you that I'm prepared to do that demux, right? I guess you could simply say that the double cipher suites indicate you're going to do that, for instance. So I guess I'm happy to take this to the list. I know I responded this on you very late, so I'm happy to take this to the list and have you think about it more. But I guess I am sad enough about us burning the details code points for this. And frankly, at the implementation effort on this, I think at this right, how invasive that is to the stack. So right now, first of all, right now it's not all invasive to the stack. Right now, all you have to do literally is the way that SRTP negotiation works in DTLS is that literally the DTLS SRTP stack only knows about it's got a list of code points and a preference setting, and it knows how to negotiate them. It knows what the meanings are. Namely, they're simply integers tied to enums, right? And so in order to implement this in a DTLS stack, you'll now have to it'll be substantially more invasive to the DTLS stack to have the extra content types, and then to find out how to plumb the data upward. So it'd be substantially more invasive. So I think so, and we don't have like an enormous number of code points either. So we have a lot free, but it's not like we have an enormous number. So I guess I'm sufficiently bent about this that I would like to discuss it. And you time to think about it, right?
Yeah. Sounds good.
So okay, so that was the first point. Second point is I guess I think the key hierarchy is kind of gross, but I'm like, I guess upon reflection, the fact that we've gone this far with it and that you already have fielded code that does EKT, I don't think it actually won't work. So I guess what I'd like to see is the diagram, and the diagram is make me absolutely sick that I think we can go along with the current thing, even though probably we've had an opportunity. If we started this 2 years ago, if I started thinking of this 2 years ago, we could have shined this in some way that would have made me happier. So I guess that's a very long-winded way of conceding I'm happy to live with the current thing. Once I see,
modulo seeing it in detail,
diagram,
right,
and having it be the thing I think it is.
Okay.
One question I didn't think to raise, but I wanted to raise now, and I think Russ is going to want to perk up for this, so to speak, is I noticed we're standardizing these AES key wrap things, and I understand that was old school, but now we sort of tend to do more stuff with GCM, and I'm wondering if in the future we should be thinking to do AEAD instead of doing AES key wrap. And maybe the answer is no, in which case it's fine, but it would be like one less cryptographic component I had to have.
This is Russ. The reason I prefer the key wrap approach is if you're going to do some piece of this with an HSM, you want to wrap the key in a different algorithm than you're wrapping data so that you know whether it exports or not.
Or conversely, so you can't use your generic descriptor. Correct. Okay.
Yes. So I hope that was captured for the minutes, but I think I understood that even. But yeah, excellent.
Thank you.
That might be worth actually.
Oh yeah, that's definitely worth writing down. So
done. Minutes.
So does the note takers know what to write it down?
Richard will take care of it. We'll get it. We got it. We'll go.
I think enough people got it. That's fine. So when Eka asked the diagram, I think that's probably that led me to remind me of my objection to this draft, which was that it sort of just gets straight into the meat of the thing without really providing any context on how it works, how the different pieces. It's basically impossible to pick up, and there's a diagram, but there's also a bunch of text that you want to add ahead of that that sort of says what the roles involved, what are their goals, why there's all that padding that you need to add to make it accessible.
Willing to help on that a bit? A bit? Okay, fair enough. Yeah, yeah.
That makes it look like you all.
Okay, any other issues we want to talk about with this draft? Okay. This draft also lacks introduction. Next slide. Next slide. Yeah, I mean, most of the changes were clarifications in there. There's no real technical things. I'm not aware of any open issues on this one. If anyone has any things they want to bring up on this. I'm not exactly sure how this registry, it's a specification required registry, but I was thinking we were about time to maybe request an early code point for this. Not quite sure actually how that's done these days.
Yeah.
The SRTP protection profile, which I went and looked, it is a specification required, is what the registry is. So.
Yeah, we've been changing the policy,
and it's not small. It's a large code point. So.
Yeah, we've been changing the policies on these registries in TLS left, right, and center, and this is one that slipped through because it's not really one that working group owns. But we should probably try to proceed on the basis that maybe someone should write a short document changing that policy.
Yeah, so I mean,
spec required is like I have a GitHub page.
Yeah, so I think we should ask for allocation. Yes. Okay. I'm the expert, so you can assume that I've said you can have one. So I guess I did want to briefly talk about the structure of the OHB. So I guess again, this is not something like I'm a hell of more to die on, but it seemed like I had trouble understanding how the mechanism is supposed to be used and exactly like who is supposed to put in what, and why they're supposed to put it in, how long it should be, and that kind of thing. And so I guess I wanted to sort of get your take on that.
So I think that right now we wrote the draft that either the initial client could insert it, or if they didn't insert it, the MD could insert it. And the more I talked with Nils about actually implementing this, the more I just came around to the conclusion, it's just going to be easier for everyone if we just have the client always insert it.
So I guess this is where I got a little. It seems to me that OHB is doing two things, right? It's a separator between the non-malleable and malleable extensions, and it's also a reflection of your claim of what was in the packet previously, right? Right. And so I guess what I would sort of ask is, would it be? It seems like the easiest thing to do would be to have the originator always insert it, and it's always the same length, and he always inserts exactly the same fields. And if we are really bent about the size of it, then some guidance would be useful. But I guess you have all these different possibilities of how long things might be, and I guess what I wonder is how often are you going to change one, not the other, and those kinds of things. It is complicated to have it be like multiple lengths. But in any case, if we're gonna say the originator inserts it, which I approve of, it should be clear, as I understand it, that with the originator, that at that point that data is entirely redundant with the SRTP header, which is fine. But I'm just saying that we should be very clear, since there's no reason for the originator ever to insert anything that is different than the SRTP header. We should be there should be an exact set of strings they should put in. Rather than being unclear, right?
Right. So I think what we might want to do before we sort of totally nail this one down is see where this whole SSRC changing discussion goes, right? Because if right now there's only the two things that can ever possibly change, it's easy to figure out once we have the definitive list of what we're going to allow changes on, it becomes clear how to minimize the bit rate, the number of bits this uses, right?
That sounds perfectly fine. So I guess my only ask would be that if we're going to tell the originator to insert it, we tell them exactly what he has to insert.
Yes. Right. Okay.
Just want to double check, Niels. I thought you had mentioned that there were things that we thought in the client we might be putting after the OHB anyway. Is that no longer?
we did, but we just agreed yes to service, that's fine. Sorry, we said the client has been serviced, that's fine.
Right, you were saying that, okay, so the OHB would be fixed, and then there'd be stuff behind it, okay, that's fine.
Right, I'm
Yeah.
just saying it should be the same thing that's in there.
It's almost just for completion. So one of the examples I came up with was basically if the client does simulcast. You want to insert the OHB and say like everything up to here is, I don't want you to touch it. But RID is basically something client goes to the SFU and SFU is free to rip that out basically because it doesn't make sense to send it to the other end.
Okay, so we need to, we've got that in a minute, right? So, yeah, no problem.
And the only other point I had about the OHB was that it would be nice to have a little more guidance in the specification about how the receiver is supposed to interpret those the values, the original values, right? Because it seems like right now, as far as I can tell, the spec says basically for all the things we tell you what to do, you use the thing that's in the packet, and the OHB is just like sitting there so you can do the critical validation. And it sounded like with your email, like there were some other side cases in which you might use the OHB itself of values rather than the ones that are in the packet. And I think that if you're gonna say that you might use them for any purpose at all, you have to give some guidance about what purposes are safe and which purposes are unsafe.
Right.
Because right.
I think that's probably also becoming more clear if we basically require the OHB to be there always, because then the text for the receiving side is also going to say like, always take the values from the OHB.
It lacks the text right now. Don't ever use these values over here for anything, right? It doesn't. It doesn't say like there's. It's clear about which values you should use for most things, and it doesn't ever say don't use the other values. And the only case I know right now is those are used for statistics occasionally. I may just put the text in, don't use these for anything except statistical reporting, right? Would anyone object to that text added to it? Yeah. Okay. I mean, I think almost 99.9% of implementations should do nothing with these except throw them in the trash.
There were some notion of like auditing to make sure your MD isn't doing anything too crazy. Well, but I guess that's kind of debugging now.
That was more useful for the remember we had all those other things that used to be in the OHB that we've mostly removed. Like a lot of why it is the way it was when we thought there was going to be more in the OHB than it is. So I think that the auditing ones were all things like the sound levels and stuff, mixer client levels. So I'm not. Maybe we've thrown out everything that's auditable in any meaningful way. That's it. Okay. Thank you.
We'll handle dispositions at the end. All right, David, framework.
All right, thank you. I think we can go right into the material. Just a couple of slides. What that is? Yeah. Mostly administrative or editorial changes. Thank you, Ronnie, because I think these were all came from you, about a dozen or so things, if from typos to suggestions of improvement, adjectives, etc. Probably the most substantive thing you did was define call processing, and borrowed some of the text from Focus in the RFC 4353, which is also really good because that's a Jonathan Rosenberg RFC, and I worked for him, so I'm using that for extra brownie points. So thank you for that. And so again, a couple of things, again, mostly in the cleaning up references, since a lot of the individual documents had flipped over to workgroup documents. So those need fixing, and added the extra row to the table showing the, who has what keys between the two NDs. I think there's a missing row. So that's kind of the long and the short of it from, again, mostly editorial changes, nothing terribly substantial. Next slide then talks about, well, what might be left to do. So we've already got a couple of issues in the GitHub there tracking the following couple of things. Now, I don't know if you recall, but way back when we first started Framework, it was an individual document and had a little bit of everything in the kitchen sink in it. We did have the packet formats, and in breaking out, which totally made sense, all the different items into diet, double, etc. That roll up of the packet format doesn't appear anywhere. So maybe we might want to consider adding that back in somewhere to Framework. I was thinking an appendix, but maybe it's in the body, that artistic choice notwithstanding. So that's one of the things identified so far. And then just as we discussed earlier, if we're going to end up having that DTLS ID be the approach we take that triggers some changes in the framework document, and perhaps also pointing to Martin's ID, assuming it goes forward. Those are the two identified. Anything else? I wasn't paying close enough attention during the diet conversation where you said maybe something needed to go in the framework. Colin, key topology.
The key topology. So let's write it and we'll figure out what draft it goes in, but I'll make an issue for it and we can track it down.
Okay.
One of us will write it for us. You're off the hook.
Yeah, right. Anything else? No, I don't hear anything, so otherwise I don't have anything else to cover. All right, thank you.
All right, that brings us to Emil's topic.
All right, so a couple of subjects to discuss. First one has to do with RTX. Next slide, please. So one thing to keep in mind, and where the reason why this starts being a consideration at all is because SFUs in general terminate RTX. When you are when you're losing packets, you want them to be restored as quickly as possible. So you'd like to avoid that being end-to-end. So you implement packet caching at the SFUs. That means several things. With Perc, in order for an SFU to be able to resend you things, that means that it shouldn't be expected to re-encrypt them or anything like that. So that basically places RTX obligatorily after the end-to-end encryption. So you first do your end-to-end encryption, then your packet is in a retransmittable state. Then that's where you apply RTX all the time. This is where you encrypt, you add the original sequence number and all these things, and then you do the hop-by-hop encryption. So that sort of has to work that way, which is not how it works with traditional hop-by-hop SRDP. So there were some mentions yesterday in AVT core about, was it payload? That this might be raising some eyebrows. Is there any discussion necessary about this, or should I move forward? Because there are other issues with RTX. No, it's all good. Okay, next slide, please. Now, another thing that RTX is currently being used for is probing for bandwidth. Specifically, Chrome does this. So you have this, and by data stream here, I don't mean data channel, but just your media. You have the sender sending stuff to the SFU. At some point, specifically when you're using things like simulcast, and you cannot just gradually increase your bit rate. You have to jump basically from one small stream to one big stream. You might want to check in advance whether or not this is actually possible on this link. And the way that you do that is, next please, you basically send a bunch of bullshit just to see if it will go through. It's a popular approach in politics. So now the way you fill that in is there are multiple approaches. You can do it with FEC. You can duplicate some packets, or the way Chrome does it, you can fill it in with RTX. Next slide, please. So the way an RTX packet that is used for probing looks like is you have the payload type for RTX. You have some original sequence number that's just random numbers. It doesn't really matter. Then you have a bunch of zeros, and that's all. The padding length at the end of the RTP packet is pretty much equal to the length of the payload all the way up to the original sequence number. So the whole thing, the whole thing about this padding is that it's a hop-by-hop affair. So it needs to be terminated at the SFU. But in order to know that this is a padding packet, you have to be able to read this thing here and compare it to the entire length and say, oh, actually that matches my length, so this must be a padding packet, so I can drop it, I being the SFU. And unless you have that, you cannot really terminate your probing traffic, so you're just sending it to everyone, not great. So basically, the thing that all this comes down to is that you need a way at the SFU to recognize such probing packets. Do you need to? Okay, next slide, please.
No, yeah, on this slide. Mozane, so I think you may have misrepresented it a little bit in payload. I think originally you were talking about using the media payload type, not the RTX payload type, and having a padding only packet using the media payload type, which was the source of the problems. And clearly, frame marking wouldn't apply to RTX or affect any other kind of packets. It's only on the actual source RTP streams you apply those header extensions. Is this working? So now that you're clarifying that you're actually using RTX payload types and formats for these padding only packets, that doesn't seem to jive with what you just said on the previous slide, that you want the RTX to only be hop by hop, basically.
Yeah.
And after the SRTP transforms. So then the MD has full control over the RTX, right? It can take the RTX and discard it.
So no,
and generate
because
its own RTX.
So you have to be able to recognize between bogus RTX packets and real RTX packets. A real
Let's back up. The first slide that you had, go back to the right there. Okay. So here you're arguing for RTX being hop by hop. That means terminated at the MD and regenerated by the MD, right? So he is discarding every single RTX that he gets from every source.
The argument that I'm making is that needs to be possible to happen. It doesn't mean that will be happening all the time, because maybe some RTX packet is sent because neither the SFU has it nor the receiver has it. In that case, you're just going to let it go through. We cannot authenticate. So you would let it go through by just replacing by just doing what SFUs do today, which is you're going to remove the hop by hop SRTP on one side and add it on the other side, but the content of the packet is going through. You receive an RTX packet with hop by hop SRTP protection. You remove that SRTP, decrypt that part, the hop by hop, and then you encrypt it on the other side, but it's the same RTX packet. Yeah, so which part of that is, that's how SFUs do things today.
But you're arguing that the MD can terminate all the RTX and it can regenerate any RTX that it wants.
So, okay, maybe terminate, I agree. Maybe terminate is not the exact word. It needs to cache. It needs to be able to generate RTX, and it needs to have packet caching. It needs to be able to introduce RTX packets into the stream. That's
right. So from a source, from an encrypted source, it lost the packet. So it's knacked that source, and then it got an RTX packet that it expected, right? And can
you say that again, please?
So the RTX came for a reason, right? Somebody knacked a packet. The MD knacked the packet towards the source.
Yes, either the MD or it came all the way. Most of the time it will be the MD, yes.
And so the MD is waiting and expecting a certain RTX packet,
and
it got it,
and
it can recover the original packet, and then it can send off the original packet, not an RTX packet, to the downstream
no, it
link.
cannot necessarily do that, because by the time that this RTX packet arrives, there's an equivalent gap that might have occurred in the receiver too. So most likely what's going to happen is that this RTX packet is going to continue all the way through as an RTX packet.
Okay, but it's MD's choice. It could do either one. It could recover the packet and send an original, or it could send the RTX either way.
Yes.
Right. So then you really shouldn't have a problem with this padding case on your second point, because the MD is the one asking for a certain RTX, and it knows whether it got RTX or not. So it should already know. It should already know whether it's a padding only packet or an RTX that it's asked for.
Jonathan, you had a comment on that, or?
I mean, the one thing I noticed about at least your example of the padding is I mean, I don't know how visible it is that, when you unwrap that, this is clearly not I mean, I'm pretty sure this is clearly not an ETD as an encrypted SRTP package, right? This is, I mean, you don't have the, you don't have the V equals 1 at the start. I mean, or I don't remember exactly how ET is encoded now, but it's not. That what you unwrap when you unwrap an all zeros padding packet is not an ETE encrypted SRTP packet.
So you're saying just let that go in the clear, and
basically and so then basically So maybe this requires some degree of MDD validating what it gets, say, does this look reasonable? And if not, I'm not going to forward it because there's nothing sensible in here. But I don't know.
I'd have to think that I wonder if you could actually do something with the fact that you're receiving an
I don't remember
authenticated.
the exact format of the ED transform at the moment. I just looked at that again.
So is there, what I'm trying to get at here is, let's say Google didn't use RTX for padding it, did something else. Then we have no problem? Like it's just.
Well, this specific problem disappears, yeah.
Okay, so this is really only a problem of how does the MD detect that this.
Discardable packets, yeah.
Well, that's a padding packet.
Yeah.
I mean, you know, if it hurts to use RTX, maybe we shouldn't use RTX for that, I guess is basically what I'm getting to. Like if this is not easy and obvious, I mean.
So maybe.
That's a wild violation of the specs, what they're doing right now, right? So.
Maybe, yes.
But we still need a way to solve their problem, but maybe there would be a different way.
Right. So now the question is, do we go and correct the word, or do we make sure that Perc wouldn't break in that scenario? And that wouldn't be yet another thing that has to be fixed before Perc is implementable in that scenario.
Yeah, Jonathan, I mean, I think that, padding has a lot of limitations, notably the max 255 bytes, which you really want to be filling MPUs here. So, I mean, maybe we need something explicitly, the thing I just mentioned, explicitly in the end-to-end transform, some way of saying, hey, this content is not an end-to-end transform.
Yep.
This is something just for the.
That's if you actually go to the 7 slide. So this is all that we're talking about here. Having some way, now this is an example with frame markings where you have one bit that says this is padding only, this is hub by hub discardable. This is what we're talking about here.
Yeah, I'm not sure it needs to be a frame marking. I think.
Sure, it can be in. We actually have an alternative suggestion at the end of the draft. You can also put it in the hub by hub header.
Mo, again, I think I'd like to ignore the Chrome specific issue for now because I think that's an oddity that you probably don't need to design a solution for. The fact that they're using RTX and padding together for probing, there's a lot of other ways you could do probing, so we could fix that problem in Chrome with those. But there's a more fundamental issue that I think we kind of glossed over here. We're suggesting that the SRTP transform for Perc is payload type specific, and that seems a little weird and scary to me. Certainly not what Double envisions. And
how is it payload type specific?
You're saying apply separate parts of the SRTP transform in separate stages, depending on whether it's RTX packet. And FEC would also have the same consideration. Right?
No. What is specific here is the way that you do is the RTX application. You would
right, but which is a payload type. So you do payload type specific SRTP operations.
No, it's SRTP specific RTX operations. Like is. It's the RTX part that would change it. It's not the SRTP.
If I had a crypto lib and the crypto lib said, double encrypt or something.
Yeah.
Give me 2 keys, double encrypt. I cannot do that anymore because now, depending on the payload type, I will either end encrypt, do some packet manipulation, and then hop by hop encrypt.
Right, but you wouldn't do it exactly that way. You would have one step end-to-end encryption, then you do some things, and you potentially add even more extension headers, and then you.
So I think what was raised in the ABT and payload sessions is that there's a fundamental need for redundancy streams, both RTX and FEC, for those redundancy streams to operate a different way than they have been operating before in the context of Perc. That's clear, right? If you want the MD to be able to participate in repair,
yeah, redundancy streams will be operating.
There is no way that
yes.
that Perc protected payloads are going to go through as is. So
yes.
So we need to find a solution to allowing the MD to do that, but hopefully not a solution where every single payload type has nuances of different SRTP transforms. So maybe when you look at doing something like a pre-crypt operation, now that we have something that tells us it's a Perc packet, you have a mandatory header that's always in there, the OHB, that identifies that it's a Perc packet. maybe something about that can help us
Maybe, yeah.
know whether this was full double or whether it was,
Right.
double wedged with something in between.
So this is all about redundancy streams. It's not about identifying discardable packets hub by hub, right? Okay.
Hi, Alice, John. Just commenting on behalf of the WebRTC team at Google. There is at the moment no bug file that has both padding and RTX in the header. Could you please file one so that we can get someone, not me, to answer why we're doing it this way? Perhaps we shouldn't be doing it.
Okay.
Yeah, I think that, to the point that, I think if you're going to do hop by hop RTX, everything is going to need to be a two-stage. You first do end-to-end encryption, and then you save the packet, the end-to-end encrypted packet in your local cache, and then you do hop by hop encryption.
Right.
And when you get an RTX, you retrieve that end-to-end encrypted packet from the cache, and do
Exactly.
click on the OHP.
And the same is mostly true of Vector.
And then send the RTX packet. So it's not going to be a single call to do double. It's going to be a end-to-end encrypt and hop by hop encrypt.
It doesn't work that way in one implementation, but that's how it needs to work.
So I have a extremely dumb suggestion, which may not solve the entire problem, but I'm not entirely following the situation. But another way to pad that would be accessible to the MD would be to pad in extensions, because those you can insert. That may not solve every problem or any problem, but I just want to throw it out there in case.
Okay. I'll mention that in the bug that I found in the Google Tracker.
So Mo, again, I'd like to stress that the problem here is not this crazy padding only probing case. There's a problem that's more fundamental. That's how do you handle any kind of repair stream?
Sure.
Let the MD participate in a repair stream in a Perc conference. That's the fundamental problem. What was proposed originally in ABT, actually the payload, was that do the repair operations after all the crypto. So full double, do that. But when you do that, then you lose the ability to authenticate the repair packets.
Sure.
Now you still have full end-to-end authentication. So when the ultimate receiver gets it, it can still be authenticated, but you open a potential vector
Absolutely.
that you can have,
Yes.
spurious repair packets that MD would, could send off. That's the core problem. And to wedge double to get authentication is the question. Is it worth it to wedge double to get the authentication, or should you just allow repair and over the entire fully doubled packet?
I thought that was so glaringly wrong that we weren't even considering that option.
The thing was, bring it to Perc and discuss it. That's what I said.
Well, okay. Well, we are discussing it, so. I'm not sure where we are right now in this discussion.
I'm not sure I followed where we are either.
So to summarize, we have two problems. One of it, how do we handle repair streams in general? Are we wedging Perc? And really, I don't see how else you could do it. Sorry, are we wedging double? And the second problem is indicating discardable packets, hub by hub discardable packets. I'm sorry? Are they equivalent?
Can you go to the mic, please?
This is Steve Bosco. The second problem that was identified was how to do bandwidth probes, right? And how to mark bandwidth probes. You were providing the solution. The problem was how do you do bandwidth probes?
Well, I guess I'd rather we avoided solving like hedging Perc on solving this entire bigger problem of bandwidth probing. I'd rather just see what people are doing currently and make sure that we can make it work with Perc. That's, I guess, why I'm.
Tons and tons of people have implementations that do bandwidth probing that do not use this approach to do it.
I'm perfectly fine with that.
I think it'd be nice to figure out, I mean, I think this is not much to do with Perc. It has to do with a sort of general problem in sort of ABT and, as a whole of what's the right way to do bandwidth probing that works on a wide range of stuff. I mean, I think that's, if we had an answer to that, we could ensure that answer works with Perc.
Well, what bothers me with this approach is that we're basically going to say, okay, we're going to tell the world how to do bandwidth probing now. And until we're ready with that work and the world has actually implemented it, Perc is not going to be able to use bandwidth probing.
Well, lots of the ways that people do bandwidth probing would work fine with Perc right now. I'm not even sure that this, I don't actually understand why this doesn't work, really.
Because, again, when you're an SFU and you see this is end-to-end encrypted, so you have no way of knowing that this is not real data.
So what happens? It sounds like...
So you send 10 megabits on down the link to the 3G receiver.
But I still don't understand why we actually send it on. Because if it's retransmission, it's supposed to be terminated in the, or at least kept, saying, okay, I use this to try to repair locally in the MD. So why is it forwarded? And I think actually Google's solution to this is actually to not use padded packets, but actually use real packets being
So the reason you would forward it, it is sort of implementation dependent. But when you see an RTX packet, it could be that you just don't trust your cache to remember that far back. And you could say, well, if it's not within the span of my memory, then I'm going to drop it. Or you could say, I'm just going to let it through because maybe the receiver knows what to do about it.
But I mean, yes, but that's your MDAD problem. Then you're limited. If you have too limited view of your history, which you need to have some history view, you agree with me?
You absolutely do. The question is, do you assume that receivers will have the same history or not?
I mean that's for RTX, etc. There is a configured horizon, which is the expected horizon, and that's part of the
configured what? Sorry.
I mean, you have a parameter in for RTX saying how deep your descender side buffer is, and that's something actually the MD should indicate towards the lower, and that's either how it deals with keeping it or being able to transmit it all the way back. So there's a parameter for the time window, the maximum time window for RTX format.
That's a thing today?
Yes, it's there.
It's the what?
I think it's the parameter in the HTTP for that RTX. You say the time window that you want to hold it for.
Repair window.
Repair window. That's part of the 45.
Okay.
18.
Does anyone know how supported that is currently?
Mo, I was going to comment on this. Are you red? Is that when you say encrypted, end-to-end encrypted on that left-hand side? Are you including the red fields, the original sequence number?
Yes.
So then that, and even in your proposal, even after the previous slide's proposal of wedging double, it's still going to be, the OSN is still encrypted?
Yes, that's end-to-end encrypted.
But that makes no sense because then you were arguing for the ND to participate in repair, but now you're encrypting the OSN. So why did you wedge double but still encrypt the OSN? That makes the ND unable to use.
No, you're
repair.
right. Yes, you're correct. The OSN is not encrypted. The padding length is encrypted. You're right.
So okay, so then there's a solution to this current problem because you didn't ask for this repair packet. So
Well, that's the
OSN
memory problem.
Your OSN will be some random number, not the one that you knacked. So you can tell whether it's padding only. You can tell whether it's a wanted RTX or an unwanted RTX. Yeah. Yeah. So, but I think that's even a bigger problem that you expect that to not be end-to-end encrypted because now the rules even just got worse. Some parts of the payload.
Did I expect that to what be, sorry?
If you're expecting that OSN, which is payload, if you're expecting that to not be end-to-end encrypted now, I think that makes
It's not end-to-end encrypted because you applied it after that, but it is hub by hub encrypted.
I think that's making the transforms even stranger and more
But that's just
hacky.
I mean, that's just part of the normal RTX transform. So I'm not sure why it's stranger. Adding the OSN is part of the RTX transform.
I had some of the same confusions here. Like, when you say end-to-end encrypted, you mean with double?
Yes.
No, it means wedging double. It means. That's my confusion.
Can someone explain what we mean by wedging double in this context?
So back up a slide. Back up. Another one. Another one.
Slide 3.
There. Okay. This is the real wedge right here.
Yeah.
This is saying that double is defined today is doing a single transform over every single RTP packet. Doesn't matter what the payload type is. Every RTP packet that comes into your stack, you call libsrtp, you say do a double transform, and you always get the same format out of it. This is saying that depending on the payload type, for some payload types, you will call a different SRTP lib function that says don't do full double, do the first half of double, do the end-to-end half of double. Now I'm going to munge the payload and header. I'm going to munge both the payload and header, and I'm going to call another libsrtp function that says do the second half of double.
Right.
But only do it for certain parts.
No,
of the
why
payload.
would you only do it for certain parts?
You just
You
said
could
the
do this.
OSN is not
No,
going
no,
to
no. You could do that same two-step operation for absolutely every packet. It just has to be wedged everywhere. And for some payload types, there would be nothing happening in between the two steps.
So on the receive side, by the way, both these options are terrible, which is to say either you receive a packet, apply the hop-by-hop decryption, look at the payload type, figure out whether you need to peel out the OSN or the FlexPack header or whatever, and then do that transform, or else do the regular decryption, or else you receive a packet, look at the payload type, decide whether you need to do the FlexPack or RTX, or pass it directly to the SRTP stack. Either way, you're looking at the payload type to decide how your decryption process works. And both of those are awful.
So, Colin Jenkins here. I'm not a fan of this at all. I think that the basic problem we're trying to solve, though, going back to it, when I think about this, it comes really to, I'm like, why aren't other people having this problem? Why don't we have this problem? And as far as I can tell, we viewed RTX was hop by hop. That the RTX that we had I think the next slide basically says that. What's the next slide here? Maybe it was the next one. Who knows? Anyway, there was somewhere where pretty much it was hop by hop. And that basically, no, the MD does not forward RTX packets, right? And then I think what Google's doing today actually works just fine. And normal RTX works fine, and basically error correction works better on a general rule of thumb if you do it on each hop versus trying to do it end-to-end, because you don't have the accumulated errors, you have better chance of repairs, fast repairs. There's lots of good reasons why we all think it should be hop by hop. So I think that really, don't have your MD forward RTX packets, and if it gets a request that is too far back in the history that it doesn't have it, well, them's the breaks. Like that's just what happens with RTX and media, and you can't kill it. And then we don't have to worry about any of this. I think that's right.
Okay.
Magnus, I actually have here, if you actually would configure all the repair channels as a separate parallel RTP session that would repair the double encrypted session, which is forwarded by the MDD, you would actually have a clear separation, and you could actually configure that other session for not using double, but only regular SRTP.
Magnus, but wouldn't that mean you're sending the repair session that basically has an OSB and then the unencrypted media? Or only hop-by-hop encrypted media, so you're exposing all the media to the...
No, on the complete full transmitted packet. Yes.
So you're sending, so the payloads of your RTX are
Double encrypted packets.
are double encrypted packets,
Yes.
including the hop-by-hop.
Yes.
Yeah.
And then they're encrypted again.
Yes.
That's what I was. Again, I think the easy way to think of repair is this is just like a link layer thing. We shouldn't even be doing it at very, very high layers. We shouldn't be mixing, these very high application layers. This is just trying to recover link level, issues. So just like you would have at a PHY layer, you may have some kind of retransmission. At a MAC layer, you may have some kind of retransmission. This is like the repair schemes that we're talking about, RTX and FEC. These are like link layer, retransmission things. They shouldn't have to worry about all the high level parts of the protocol. Send the whole damn double packet again. FEC the whole damn double packet. And if you want to triple encrypt it again, fine, no problem. So I think we should think about these repair flows.
Okay, now
whatever the payloads of them are.
As much as I think that I don't immediately see a problem with Cohen's suggestion to, well, you make sure that packets that you haven't asked for, you don't forward. I don't immediately see a problem with that. Not wedging double so that you would, and allowing double packets to just be resent has very glaring problems that we discussed yesterday. So I don't know why we're still discussing that. That basically means that anyone in your link will be able to introduce these packets and potentially cause trouble with that. So I don't know why we keep going back to that.
Mike, please.
No, if Mo's suggestion was this is just link layer, just keep retransmitting without doing anything.
I would say that you would need to have a third level of security for those retransmission
Okay,
packets.
so we mandate IPsec in Perc, or
No. You can use SRTP. That's the third level of SRTP.
Oh, okay, that could solve it.
Because you have created new packets when you do SEC or retransmission packets. They are new. They're not the same as the original ones. So, and then you encrypt those, or at least authenticate them.
I can't tell if you're serious.
You only
or...
need to authenticate them. That's what you protect.
Why do you need the original hop by hop? Yeah, thank you. I don't know either, but I'd like to know.
Yeah, so, so my question is, why do you need the original hop-by-hop encryption? And the answer seems to be because it makes Cullen's implementation easier. My question was, why, in the case that Magnus just described, why do you need the original hop-by-hop encryption in your retransmission? And the answer seems to be because it makes Cullen's implementation easier. But if you don't have the original hop-by-hop encryption...
Well, you need the authentication part of it, not necessarily the encryption.
To make this deploy, I think that we should architecturally try, and it was said earlier in the meeting, minimize the changes to endpoints. So as much as we can make endpoints do RTX when doing double, do it exactly the same way as if they were doing, fubble or the next transform we've defined. Like, why should anything change?
But we can. No, we can't, because right now, RTX is done before any encryption.
Yes.
Which means in Perc, it would be invisible to the MD.
Yeah, I was going to say, so, do folks, it sounds like, is there agreement here that's, okay, Jonathan, let's focus up. Is there agreement here that there is a problem to be solved with regard to repair streams?
Ronnie Evan, in payload yesterday, there was discussion also about FEC with the same issue, that when you do the FEC before SRTP or after SRTP, and it was agreed that we'll do it in pair.
Okay, great. So maybe we should have a call about this and a more focused discussion. Do folks think, let me ask, frame this as a general question to the room. The question here procedurally is this something for which double needs to be held? Do we envision there may be some changes needed to the transform itself? Or is it more likely that we'll end up with some recommendations about how you use that transform?
Well, some of the solutions that we're discussing do imply potentially adding bits to OHB, so they might require help from double.
Okay, so we'll try and have this conversation quickly then, so that we can try and meet the milestones. Yeah. We'll have a virtual interim and hopefully some discussion on this.
Let's move on then. This brings us
5 or 10 minutes on this.
Oh, okay. This This is a debate that we had in Berlin. I took it as an action item to do a draft that sort of goes into a little bit more detail, and I've only been able to do that now. For that, I apologize. It all comes down to the fact that in some SFUs, this is not a law of nature, but in many SFUs today, the way you implement simulcast is you have 3 different SSRCs, 3 different timestamps coming, and you let only one be visible to the user. It might be one of the 3, it might be yet another one. It's a single timestamp space and a single SSRC space, which means that you need a way to be rewriting these things in a Perc, in a double stream. Next slide, please. So basically, the first way we thought of doing this is.
Can you go back to the previous slide?
Yes.
I disagree. Explain why you need to rewrite those things.
So I
Almost
don't want to go
1, 2,
in.
and 3 are the same, right? Because they came from the same sender, it's simulcast. So they're not different. Let's just call them timestamp.
No, they are not the same today.
They refer to the same wall.
They can be the same, they're not the same today. So one packet over these 3 streams does not necessarily have the same timestamp value. Sorry, that one frame in.
Not the same.
No, they don't have the same timestamp value in the same frame over the 3 streams does not have the same timestamp value.
No, you're saying this is a choice that the SFU can make, whether it's doing switching or rewriting. Because all SFUs don't operate this way.
I didn't say all SFUs operate that way,
You're
but
saying-
many do.
Okay, you're saying that the choice is to either create a new SSRC 4 and timestamp 4, or you could switch dynamically between 1, 2, and 3.
No. The point
With
is,
Chrome 58, you can switch 1, 2, and 3.
you can switch 1, 2, and 3 as a
You
Chrome
can switch
58.
between 1, 2, and 3. You can output whatever is you want to forward, 1, 2, or 3 at that amount at that time. At every frame, you could switch between 1, 2, or 3 if you wanted to. Oh, at a reasonable time scale, you could switch. You don't have to rewrite the SSRCs and timestamps. You can switch to the one that you're actually carrying.
So that's
Dynamically switch.
Mo, that's the change with Chrome 58 now. Did you say that's the change with Chrome 58?
It's standards wise, you could always do it. Chrome
Yeah.
had a bug where it didn't support it
Yeah.
until 58 now supports it. Sorry? On reception, yes. Yes.
Okay, we'd have to look into that. I'll go quickly through the rest of the slides just in case, and we can hold the rest of the discussion for once we've seen what Chrome 58 does.
Adam Roach, I have a fundamental objection to engineering around implementation bugs, right?
This is not engineering about implementation bugs. It's what Mo is talking about is that potentially Chrome 58 may make it unnecessary for that to happen. That's one single implementation. What I'm talking about is that this is what SFUs, many SFUs, not all of them, many SFUs do today.
Well, and how many Perc SFUs do this?
So we go down to the same thing. Are we going to make Perc, do we want an objective where Perc is implementable by existing SFUs without requiring them to change their entire design, or are we going to make it work for them?
Okay, that's reasonable. Thank you.
Okay.
I also want to say this is a reasonable design choice because for smoothness of switching, it's much cleaner to have the RTP timestamp contiguous than trying to have to do it effectively with lip sync between the simulcast streams. You get a much smoother switch this way. So this is a reasonable design choice, not just a implementation. Think of it as a working on other people's implementation bugs. So the answer, so in the RTP spec, the timestamps of those 3 streams are supposed to have independently randomized initial values.
They all map to the same.
They map to the same NTP time, but if you have any kind of clock drift, your NTP time to RTP time mapping updates on every RTCP receipt, but otherwise tends to drift a little bit. Because they're all RTCP packets might be set at a different time, because they're supposed to be scheduled independently. I mean, there's, with a lot of common implementation shortcuts, this won't happen, but, those are technically implementation shortcuts you're not supposed to do. So there's a slight drift, and then, it's only as good as, lip sync is good to, probably within, 100 milliseconds, which is good, or less. Yeah, but 20 or 30 milliseconds, it's supposed to be within 20 or 30, but it isn't always, and there'll be a little bit of a glitch at the resolution change. So, and this makes things much simpler for the receiver receiving inputs. Is a theory. I mean, maybe it depends on the receiving inputs implementation.
Yeah, so particularly, Colin, if say things are getting reordered, right, and you don't have a single sequence base, so the receiver has to reorder things, and the way they typically do it is they'll act like they have they'll create virtual receivers, and then they'll end up mixing stuff. So it can definitely be done. It's just a little more complicated implementation, and if you don't have somebody really good coding it, they're probably going to mess it up. That's the only difference. It's not like it can't be done.
But what the specs say is you should be doing the more complicated implementation version of it, where you do figure out the real time that it was sent in the same timeline, and there is no clock drift in the NTP time between those SSR 1, 2, 3. I understand.
We are actually observing clock drift between them for reasons that we haven't been able to explain, but there is drift.
So that is unquestionably a bug in the sender's implementation. There's no way to say it's not a bug.
Sure.
If they did the correct thing. So though I understand there may be implementations that took bizarre shortcuts that cause clock drift in sending, for example, or in how they repair the buffer, I'm like the statement you can't do this right is I'm still not finding it.
So from the Java room, Sergio Garcia is saying, SFU should do SSRC rewriting in order to avoid SSRC collision between same SSRCs coming from different participants.
Yeah. Another thing which affects this is that you actually let the different simulcast streams go through. You have the problem of terminating one. If they just switch between one to the other, they need to line up, and you need to ensure that, okay, can I actually feed this into the previous decoder and all those things? And then you need to have all the simulcast information going through to the
I think Mo is saying that this is now supposed to be supported in Chrome 58, which really I'm very surprised to learn, but I would love to test that. Can I just finish because we don't have time. Let's assume that SSRC rewriting is necessary and we've decided to do it. One way to do it with current Perc, with current double, would be to say, well, we extend this whole logic about the length and reading into what the extension is actually carrying, reading into the length to decide what the extension is actually carrying. This is the combinations that you end up with. If the length is that much, then this is what's in the packet, with some disambiguation necessary for the length of 6 and the length of 4, and that this disambiguation is done with the extra bit in the payload type. Now, the problem with this is that you're out of options. Beyond this, if you need to add one more thing that you need to put into the original header block, well, you're done. You have no way of doing that. So next slide, please. So the same Sergio that just commented came up with this thing where you actually need to be able to override the marker bit too. And the reason for that is if you have SVC streams and you decide not to forward the entire frame, the upper layers of some frame, then that means that you have to set the marker bit for the last packet of the lower resolution frame, which means that you need to add that to the original header block extension too. And as I said, you can no longer do this, so you need another mechanism. So the other proposal that we had here is, let's forget about reading too much into the length. Let's add 1 byte and just use the separate bits in here. And we can add one that says, by the way, that this is a padding only. Next slide, please. I'm sorry?
1 minute.
Okay, I'm done. And we can add also the hop by hop. Sorry. These are the same, actually, so I'm not sure why I added one more. So we have 2 zeros left. That's great. So we can, it's about this, adding this extra byte, instead of reading too much into length, adding an extra byte and indicating what the OHB carries within, with that mask here.
Okay, to summarize. So
Would it be possible to just give 1 minute for comments on this one? Because I feel it's a pretty major change in double, and I'd like to hear if anyone has any immediate comments. Again, it means not reading too much into the length. Length is just length. And we're saying what the extension carries with this bit mask here.
Let us not quite shed the structure until we decide whether we need to quite shed the structure.
I wasn't really calling for a decision, but just any immediate concerns that we.
I don't think I would necessarily build it this way. I guess, like, I'd like to understand what has to be in it. Maybe a bit mask is right, maybe a bit mask is wrong. But like, a normal time, like shedding like the correct data structures, like let us not worry about this one until we know exactly which things have to be in and out, and what combinations are possible.
Okay, that's fair enough.
Is this just encoding change, or are you asking for something different that we haven't previously been allowed to change? Just an encoding.
Both. The marker bits needs to start changing.
And the SSRC.
And the SSRC and timestamp, potentially.
I just want to point out from a process point of view that, like, the OVH used to be defined in a way that made it so you could probably change most of these things, or it could, it was flexible, you could do all kinds of things. Then we ran a large working group process, including many calls, interim meeting, to specifically go down the list and figure out what needed to be changeable. And we came to consensus on something, which is what's reflected in the current draft. And we're now reopening that whole conversation.
Well, I would argue about the validity of that consensus.
I've not heard a motivating need for any of these yet. So I'm not very keen on reopening that.
I agree from the process perspective, we should try to avoid reopening decisions, but we need to be able to address real technical issues. So what we need to pin down is what the state of the art is, whether there's a need for these changes. Sounds like this could be another good topic for a call to try and have this nailed down. So I think we need to move on now, but thanks for the overview, Emil. So we'll get calls scheduled in the next few weeks for this and the repair stream issue. All right, so time to wrap up. Flip back to the chair slides. So reminder, we've got a bunch of milestones due in June, which is not too far away. These existing documents, we've discussed some today. Sounds like several of them maybe need one more revision before last call to address some comments today. I'm looking around at the authors, Fluffy, David, where'd David go? Like, are we ready to issue last call on these docs, or do we want to give the document authors like a few weeks to fix things and then last call?
I mean, I think we came up with some changes that were needed in pretty much every doc, including, most importantly, the lack of overview that makes them more understandable. And it seems to me it would be a good idea to get that in before we work into class.
All right, so if we are, if we're going to continue to try and meet this June deadline, which be nice to do for once. If we put out a deadline of, say, the 1st of May, which gives you about a month to make these updates, would the authors find that reasonable for getting updates in? Fluffy is nodding a little bit. Okay, Paul, yeah, nodding. Okay, so let the minutes reflect. The authors will get docs updated by 1st of May, and then we'll issue a round of last calls. With regard to the question marks down there, it sounds like DTLS ID is overcome by Martin's draft. Adam's going to do another round on the WebRTC doc, and then we'll reconsider. Is Christian here to talk about? Is it a proposed? Okay, Christian's not here, so yeah, we can talk about that as we hit our milestones and free up. Any other business for this group today? All right, well, thanks everyone for your time. Thank you so much. Yeah. We don't open up this something again. We should. How do we, like, even in the design call, how do we basically avoid getting that? I think this conversation is happening right now. I think the best case outcome is for and second best is for to articulate a really clear case that we can say that's
So he used to, like, he used to come up with a case why it's required, right?
This is the example case that came up.
Like some is that clear enough? What is it called? Yeah.
And so their existing behavior is relevant, but not responsive. Okay, you didn't know they were positive. Yeah, it's positive fact, it's something as a fact that causes sufficient activities. Okay, so it's relevant, not always.
Okay. So in that case, they are willing to change.
Well, we can decide to require.
Okay.
We can decide.
Okay.
So the question is that.
Yeah, it's interesting. Because no matter how many times you open up this discussion, it more seems like, you know, at one time.